Welcome to Lesson 5 and our types of solutions and solubility curves. Our lesson objectives: determine if a solution is unsaturated, saturated, or supersaturated based upon the appearance of the solution, as well as using table G in our reference table. So we have three different types of solutions when we want to dissolve a solute in our solvent. So initially, as we start to put a solute into our solvent, it's going to dissolve. And recall what's happening is that the solvent molecules are attracted more to the solute than the solute is to itself, and so it starts to break it apart. And we can keep adding more solute to a certain point, which we call saturated. Saturated means we can no longer add any more solute. It's not going to dissolve. In fact, if we add any more, we're going to see it fall to the bottom of our solution. Why can't we add any more? Well, recall I said that the solvent is attracted to the solute and it's pulling it apart. And so what happens in a saturated solution is we simply just run out of our solvent. There's no more solvent to interact with the solute. How do I know that I'm a saturated solution? Well, if I add any more solute and it falls to the bottom and it doesn't dissolve, we know we've hit that saturation point and it's completely saturated. Now, what happens if we heat this solution? Well, if we heat this solution, that means we're going to be able to dissolve more. And we create what is called a supersaturated solution. As we dissolve more and let the solution cool back down, that dissolved solute is going to stay in solution. So we've essentially added more than we normally could fit into that solution. But this is really unstable, and so what happens is any slight movement or agitation or some extra solute crystals placed in is going to allow it to precipitate out. And so it's essentially going to fall out of solution. And we're going to see crystals forming throughout our solution. And if you look, since we've added more solute over time, the concentration, the amount of solute dissolved in solvent is increasing from unsaturated to saturated to supersaturated. So let's check your understanding. Can you determine if a solution is unsaturated, saturated, or supersaturated based upon the appearance of the solution? Now let's look at table G in our reference table. This is a table of solubility curves, meaning it shows you that at various temperatures how much solute, whatever the line is representing, that we can dissolve in 100 grams of water. If you notice, most of the lines are increasing. These are solids because as you increase temperature, solid solubility increases. And then we have three lines, HCl here, NH3 here, and SO2 here. These three lines represent gases, because recall that gases decrease in solubility as temperature increases, because as we're increasing temperature, they're moving faster and faster, and they're moving further apart, and therefore it's harder for those intermolecular forces to come into play. So since each line represents the saturation point for a specific substance at a specific temperature, if we look at this one here, this is KNO3, potassium nitrate. And so let's look at a specific temperature. Let's look at 40 degrees Celsius. At 40 Celsius, the maximum amount of solute that I can put in 100 grams of water is my saturation point, which is about 65 grams. So that means I can't dissolve anymore. If I am less than that, if I've only put in, let's say, 40 grams, that means I'm under my saturation line, so I'm unsaturated. And if I somehow dissolved more than 60 grams, I would have to have heated it, then I would have a supersaturated solution. So depending on where it falls in this line, it tells you if you've created an unsaturated, a saturated, or supersaturated solution. And again, this 100 grams is for the water here. It's how many grams of water is represented. So these values are how much solute you're dissolving in this 100 grams of water. And so for a typical problem, you're going to locate the temperature that's listed, as we did here, and then you're going to go up to the line, and you can determine then what type of solution you made. So let's see some examples. The first example is going to look at a question where it's asking what type of solution did you produce. So if you dissolve 50 grams of sodium nitrate at 30 Celsius, what type of solution did you make? So first, there's a lot of lines here. Let's first locate the correct line and make sure we're looking at that appropriately. And so I would say on a reference table, you could highlight that if it's for an exam, etc. So here's sodium nitrate, so I'm going to highlight that for us right here. And it says we dissolve 50 grams at 30 Celsius. We want to figure out, is that unsaturated, saturated, or supersaturated? So let's locate 30 degrees Celsius, and we're going to find 50 grams here. So here's 30 Celsius, 50 grams is right here, and so right here at this point, that's how much solute we dissolve, 50 grams. And at 30 degrees Celsius, we could actually dissolve up to the saturation point, which is about 95, 96 grams. So we're well under the saturation point. So we've created an unsaturated solution. In this example, we're going to look at how much will dissolve. So according to table G, what is the maximum amount of potassium nitrate that can be dissolved in 100 grams of water at 60 Celsius? So the maximum amount is going to be saturated. So that is going to be on the line. That's the saturation point. So I'm going to locate 60 Celsius, my temperature first. And of course, we want to figure out where is the line. So potassium nitrate, KNO3, is right here. So I'll highlight that first. And then look at our 60 Celsius, which is right here. I'm going to go up to the line. And then I'm going to go across and see how much at the saturation point I could dissolve. If you look across here, it's approximately, I would say, 108. So that means we can dissolve approximately 108 grams of potassium nitrate at 60 degrees Celsius. And these are approximations, and you're given a little bit of a range when you give an answer. Let's look at this example. This is for adding solute. It says a solution of potassium chloride contains 20 grams of KCl in 100 grams of water at 30 Celsius. How many more grams of KCl must be added to make it saturated? So we're starting out with an unsaturated solution. We put 20 grams in already, and we want to figure out how much more can we add until it reaches its max point, its saturation point. So let's find our solubility line, KCl, and that's going to be right here. And so we're initially starting out with, at 30 Celsius, 20 grams initially. So we're right here, and again, we're well under the line, so we are unsaturated. We want to figure out how much more can I add to that 20 to make it saturated. Which is at the line here, and we go across. So the saturation point we see is about 35 grams. That's how much, that's the maximum amount I could add. But remember, I started out at 20, and I am going to 35, so 35 minus 20 means I can add 15 more grams to that initial 20 to get us to 35 grams, which is saturated at 30 degrees Celsius. And let's look at one more example. This is if you do not dissolve in 100 grams of water, what happens? So this chart is set up for 100 grams of water, but what happens if we use less than that or more than that? So 50 grams of water or 200 grams of water. So this question says, according to reference table G, the amount of NH3 that can be dissolved in 200 grams of water at 30 degrees Celsius is. Okay, so the first thing you do for these problems is you solve it normally as if it was for 100 grams. So 30 degrees Celsius, and we're looking at NH3. So we'll find our line here, NH3. I'm going to find 30 degrees Celsius, and the maximum amount, our saturation point, is going to be 45 grams. I can dissolve 45 grams of NH3 in 100 grams of water at 30 Celsius. But now look at the question. It says we're not dissolving in 100 grams, we're dissolving in double that, 200 grams of water. So if I have more solvent, that means I have more water to interact with my solute and then pull it apart. And so if you imagine it this way, if this was, let's say, our 100 grams of water, and now we're doubling it, a much larger beaker full of water, I have more interactions. And so I can double the amount of solute that I can dissolve. So instead of 45, I can dissolve double that, which is 90. So we can get 90 grams dissolved in 200 grams of water. And you could be asked the same kind of question for 50 grams of water. If we can dissolve 45 grams in 100 grams, then if we only had 50 grams of water, that's half of that, I can only dissolve half the amount, which then would be half of 45. So let's check your understanding. Can you determine if a solution is unsaturated, saturated, or supersaturated using table G? At this point, you should be able to determine if a solution is unsaturated, saturated, or supersaturated based upon the appearance of the solution as well as using table G in your reference table.